Welcome, students, in the lecture series of digital electronics. In previous lecture, we already discussed the RS flip-flop or latch, clocked RS flip-flop, clocked SR flip-flop, and D flip-flop. Today, we will discuss the one important flip-flop which is used in sequential circuit. It is called as a JK flip-flop. Normally, the JK flip-flop is an advanced version of RS flip-flop with removing the indeterminate state. In RS flip-flop, when R equal to 1 and S is equal to 1, the QT plus 1, it is indeterminate, or some circuits say it is an invalid state. So at the time of practical application, the RS flip-flop is not widely used. A reason behind is that it is indeterminate state is occur at any momentary of time, and the whole circuit behave like as a unlogical. So today we will discuss how the JK flip-flop is a refinement of the RS flip-flop, in that the indeterminate state of the RS flip-flop is defined in JK type. The input J and K like as input S and R. Okay, J is like as S and K is equal to like as an R. Remember that thing. To set and clear the flip-flop means J is for set and K is for reset. Let me write down here. J is for set and K is for reset. Okay, so the circuit, there is only simple difference is that there is a two feedbacks are there, back-to-back connection. Here in the basic clocked RS latch as well as whatever the Q is here, there is a three input in the NAND gate, and one is Q, and for the second flip-flop, the second AND gate, Q dash is connected. Two AND gates are there and two NOR gates are there. So remember the thing, when inputs are applied to both J and K simultaneously, the flip-flop switch to its complement state. Thus, if Q equal to 1, the switches to Q equal to 0. Let's see the behavior of that thing. So it will be make more clear how we can refinement of the indeterminate state here. Again, let me revise you. Qt plus 1 is the next output. This is the present output. Present output. When clock pulse is equal to 1, the Qt1 will be changed to Qt plus 1, means the next state. Okay. The truth table is that we have a three input Q, J and K. Three inputs are there in the circuit, and the next output is generated after the clock pulse. So this is my clock pulse. Once clock pulse changes to 1, the output is known as a Qt plus 1. And when the clock pulse is 0, at that time, what is the condition of Q? It is known as a Qt. Okay. It is very important phenomena is that. What is the difference between Qt plus 1 and Qt? It is the uh, value of the output of any flip-flop or state of the output of any flip-flop just whenever the clock pulse will become enabled. Okay. Now there is a 3 input, so that means 2 raised to 3, 8 combinations are there. So first is all are 0, 0, 0. Q is 0. Q dash is 1. Okay. J is 0 and K is also 0. Clock pulse is 1. 0, 0, 1, the AND operator is 0. 1, 0, 1, the AND operator is 0. Both are 0, 0, the output is 1. 0, 1, the output is NOR gate is 0, because 0 plus 1 whole bar. So 0 plus 1 is equal to 1 and whole bar is equal to 0. 0 plus 0 whole dash. So 0 plus 0 is equal to 0 dash and 0 bar is equal to 1. So it will become output is 0 means no change. Qt plus 1 is equal to Qt. Next is 0 0 1. Now here suddenly k is changed to 1. Remaining everything is as like as a previous case. So 0 1 1. Any one input is 0 0. Remaining 1 0 1 0. Both are 0, so 1 0 1. The result is 0. Okay, if any one input is 1, the result is 0. So here it is called as a reset because the case reset input is there. Next is 0 1 0. While k is 0 and set j is changed to 1. So here the gate number 1 output is remains 0, but 1 1 1 the gate number 2, now the output is 1. If any one input is 1, the output is 0, so q dash will become 0. Okay, 0 1, 0 plus 1, 0 or 1 will be 1 and 1 complement is 0. Now this 0 is applied to here. So 0 plus 0 bar is equal to 1. And this one again here, but this one will not affect, already one input is 1. So it 1 plus 1 whole bar is equal to 1 bar equal to 0. So the stable condition is that the qt plus 1 is equal to 1. It is called as a set state. Now the important thing is the next 0 1 1. Q is equal to 0 and j and k are 1 1. Q is equal to 0 1. So 0 1. This 0 will be go here. This one will be go here. Now j equal to 1 and k equal to 1. If any one input is 1, the result is 0. All are 1 1. In NOR gate, if any one input is 1, 0 plus 1 is equal to 1. 1 complement is 0. Now this 0 will pass here. 0 plus 0 whole bar is equal to 1. And this one is goes to here, but due to the one second input is already one stable state, 1 plus 1 whole bar is equal to 0. So we get the qt plus 1 is equal to 1 here. Okay. So what we found that if both inputs are 1 1, at that time the qt plus 1 is the complement of qt. Okay. Now suppose the q is equal to 1 and the same table will be repeated again. Let's see each and every condition what happens. One by one we will discuss when the previous output is 1 and input will become changed. So 1 0 0. Q is equal to 1 in this condition. Now first condition is J0 K is 0. If any one is 0, the result is 0 0 0. If any one is 1, the result is 0. Both are 0, the result is 1. 0 plus 0 whole bar is equal to 1. So the output is remained 1. It is called as a no change. Qt plus 1 equal to Qt. Next state is possible. The Q is 1 and J is changed. J is 0 and K will become 1. Okay. 1 0. So Q dash will become here 0. Q is 1. K is changed to 1 and J is 0. So 1 0, 1. Now what happens in gate number 1? All three are 1, so this will become 1. 2 are 0, so the gate number 2 output is 0. 1, 0, if any one input is 1, the result will become 0. This 0 is reflected here. Both are 0. 0 plus 0 is equal to 0. Whole bar is equal to 1. So Q dash will become changed to 1. This one will become given to the input of gate number 3. 1 plus 1 is equal to 1. Whole bar is equal to 0. So QT plus 1 equal to 0. And it is called as a reset. Okay. Next state is that Q is equal to 1 and Qt j equal to 1, k equal to 0. Okay. Here we will change the value of j and k. So Q is equal to 1. This one here as well as the 1 is reflected to the gate number 1. 0 is also reflected here. The value of j is 0 and k is equal to 1. So j equal to 0 and k equal to 1. In the gate number 1, all three are 1. So 1, 0, 0, 1, 0. If any one input is 1, the result is changed to 0. And this 0 will reflect here. 0 plus 0, it will become 1. So this is the 1 plus 1, 0. It's stable state and it is called as a, the next state is reset. Okay. Now j is equal to 1 and k equal to 0. Let me clear first all the previous condition of JK flip-flop. So in this condition is that the j is equal to 1 and k equal to 0 while the q key is equal to 1. So this one will be reflected here. Q dash is obviously 0 and clock pulse is applied. J equal to 1, k equal to 0. So both the gate number 1 and gate number 2 0 0. 0 plus 0 is equal to 0, whole bar is equal to 1. So 1 plus 0 is equal to 1 and its complement is 0. 0 is applied here. So now the Qt plus 1 is equal to 1. It is called as a set condition. Okay. Now when Q is equal to 1 and J and K both are equal to 1 1. This K is changed to 1. So this Q is reflected here and Q dash is reflected here. So 1 1 1. When 1 1 1, the output of the gate number 1 is 1 and gate number 2 is 0. 1 plus 0 and 1 plus 0. So let us think here. 1 plus 0, if any one input is 1, the output is 0. This 0 is applied here. 0 plus 0, the output is 1. Now this one is applied to here. But due to the already second input is 1, the output is remain 0. So it is the Qt dash is there. Okay. That means we obtain the output like as 0 1 0 0 0 0 0 1 1 1 and 1 0. So 0, this one state 0 1 0 1 0. Okay, in 0 again 0 1 1 while 1 1 0 0 0 0 and 1 and 1 1 0 1 1 0 this one. So outer cell this one is Q dash and this will become J. So this is called as a J Q dash. While these two cell Q and the value of k dash. So it is k dash q. So the characteristic equation of JK flip flop is JQ dash plus K dash Q for the next output. And the truth table graphical symbol is that J and K two inputs are there, Q and QT plus 1 are there. Remember that thing? When the J and K both are 1, it is also say that the output is complement of the previous output. So this condition is also called as a toggle. Toggling, toggling the output means the whatever the output will become complement in the next state. If the present output is 0, the next state is 1. If present output is 1, the next output is called as a 0. So some book is say that it is a flip flop, and some book is say that it is a toggling of the previous circuit. So in this way, we can understood that thing. The J and K both are equal to 1, which condition is an invalid condition. So to avoid this undesirable operation, the clock pulse must have a time duration, which is shorter than the propagation delay of flip-flop. Now here the question is arise. Suppose here the clock pulse is given as already symbol is drawn here. What happens when the J and K both are 1? This is a very one serious issue, or we can say that it is a one disadvantage of JK flip flop. Suppose the J equal to 1 and K equal to also 1, and at that time the QT is equal to 0. QT equal to 0. And once the clock pulse is 1, the QT plus 1 equal to 1. Now remember that thing at that time. Again that time the whole propagation delay of the flip flop is changed. This is the propagation delay PD of gate number 1 and 3, and reverse back the Q is changed. Okay, understood that things. So again the flip-flop output is changed and it will become 0. And at that time the next output is 0. After the clock pulse the output is also 0. Why this is happened? The propagation delay, propagation time of flip-flop is lower than clock pulse. Always the clock pulse time, suppose the clock pulse duration is half of the propagation delay. Okay, suppose my propagation delay time is larger of this clock pulse width this much. So once it changed to 0 to 1, but the flip-flop output QT this one, at that time the clock pulse is changed to 0 and this will become changed to 0. So the output never change and it remain 1, and it will satisfy the truth table. The clock pulse width is must be shorter than the propagation delay of the particular flip-flop. Else, toggling will become complicated and we cannot predict that thing. Sometimes it depends on the width of the clock pulse. Sometimes the QT plus 1 is equal to QT whole bar, or it might be possible that the QT plus 1 is equal to QT. Okay, let's. It is very important thing. So let me elaborate it. The same thing is in the one blank slide. Is that how the thing is possible? Example that the G and K both are equal to 1. Okay. Propagation delay time is 10 microsecond. So in 10 microsecond, the output is stable. And the clock pulse, suppose in first condition, the clock pulse is 20 microsecond. So in 20 microsecond, Again here it is 20 microsecond. What happens if Q is equal to 1? First it will become 0 in this condition. After 10 microsecond, again the value of Q flip-flop is enabled. So it will again Qt plus 1 is changed here and it will become 0, 1 to 0. And when this 10 after 10 microsecond the input is changed, but due to the clock pulse is disabled, the output remains same. Once again here, okay, once again this 0 is up to the next clock pulse width. Again 10 microsecond it is 1. Again it reflect to the input and it will become 0. And after the clock pulse it remains 0. So Qt plus 1 is equal to Qt. And this is toggling effect. Two or even time complement occur. So better that thing, the width of clock pulse time is always less than the propagation delay time. This is the one solution. Or second solution is that age trigger flip-flop. Okay, suppose understood like is in reverse order. The propagation delay is 30 microsecond. What happened in the same condition? Let me first clear. The propagation delay time now is it is a 30 microsecond. So the whole situation will become change. Q 0 change to 1, and this one will be going to after the 30 microsecond, but after 20 it's 0, so the clock pulse is disabled, and so it is not change here. Okay, so it will remain 1, sorry. Now again here 1, so the output will become 0 and 30 microsecond is required before that. उससे पहले ही flip flop disable हो जाएगा. So this 0 will be continued. Qt is never changed. So the clock pulse time is always less than the propagation delay time. Or second solution which we will discuss later, it is called as a age trigger. Age trigger clock pulse. Age trigger clock pulse is also one of the concept where the flip flop is only active when the age trigger is generated. At the time of age here, only this moment of time the flip-flop is enabled, remaining all time. Here it is disabled, as well as in this condition the flip-flop is disabled. So this is called as a positive age. This is called as a negative age. How it can behave here, the age trigger flip-flop, which we will discuss in later on. I hope is it making sense and you got the idea beyond the books about the JK flip-flop. So have a good day.